All right, we will get started with our first presenter. We're really excited. This is the first time the CSC and IMATS is holding an art and tech competition to make use of visualization walls. So we're really excited about this. We've got 4 amazing presentations, super impressive. So congratulations to our finalists. First up, we have Lindsay Weisskopf, who is Barnard College student majoring in computer science. And this project will be an interactive wall, thinking about collective memories and interactions. So, would you like me to share the screen? Or would you like to?
Okay. Actually, yes. And this is not the number that's stupid. I have to get
Okay, so hi everyone, my name is Casey, and this project is, it explores ideas of collective memory and nostalgia and the ways that we tell stories and then interact with each other's stories to better understand and kind of enrich our memories through the interaction with one another. So during this presentation, and there's going to be a bit of audio during this, as well, I invite anyone who's here to go up to the board and touch the screen or drag your finger across the screen when you hear part of the audio that you resonate with or anything like that. And then when this audio is played in the future with this visualization, those interactions will become part of the visualization. So they'll always be there for the future times that it's played. Without further ado.
This project is a tribute to my friends, my time at Barnard, and the growth that I've experienced over the past 4 years. In a time period that has been more discontinuous than constant, I feel ever more grateful for the unconditional support, the unwavering presence, and the light that the people in my life have inundated me with. So now I'm taking this time to reflect. And I'm taking this time to express my gratitude for these people and these memories in a way that others can connect with. Because maybe you relate in some way too. Or maybe you don't. But nonetheless, if something resonates with you, interact with the visualization and know that our memory is a collection of interactions with each other. And that can be as permanent as a lifetime or as permeable as the lifetime of this visualization.
There's a tea chart that hangs in the kitchen of our senior year suite. It has the names of every roommate and a color-coded list of all the teas we house in our cabinet. With a tally mark, it records every single tea bag used this senior spring semester. A professor once told me a story of his ritual to bring a cup of tea in the very same mug to his wife every couple hours as she worked on her senior thesis over 20 years ago. I considered it the sincerest gesture I had heard of to date. To know my roommate's tea choice, their favorite mug that it goes in, and when they really need a cup, and for them to know the same of me, provides an immeasurable sense of warmth. And as I sit to write the acknowledgement section of my senior thesis, my way of thanking them is not only for the vivid image in my mind of the smiles we shared, but also of the cups of tea tallied, sipped, and made with care.
When I look back at my senior year, it will be the simplest moments like these that I will remember the best. Every prayer seemed long to me at that age, and I was truly bone tired. I tried to keep my eyes closed, but after a while I had to look around a little. And this is something I remember very well. At first I thought I saw the sun setting in the east. Then I realized that what I saw was a full moon rising just as the sun was going down. Each of them was standing on its edge with the most wonderful light between them. It seemed as if you could touch it, as if there were palpable currents of light passing back and forth. I wanted my father to see it, but I knew I'd have to startle him out of his prayer, and I wanted to do it the best way, so I took his hand and kissed it. And then I said, "Look at the moon," and he did. We just stood there until the sun was down and the moon was up. They seemed to float on the horizon for quite a long time, I suppose because they were both so bright and you couldn't get a clear look at them. And that grave, and my father and I were exactly between them, which seemed amazing to me at the time since I hadn't given much thought to the nature of the horizon. My father said I would have never thought this place could be beautiful. I'm glad to know that.
One of my fondest memories of a really good friend of mine was when we were doing a road trip through Colorado, and she loved to sing. She was not a good singer at all, but looking out the window, she could not help but burst out into Rocky Mountain High by John Denver while we were driving through the Rockies. And I miss her very much, but that is just one of the funniest and happiest memories that I have of her just belting out while we were, in a car, this awful rendition of Rocky Mountain High. And I think of that very often.
Last summer, I was in the car with my brother and my cousins, driving back from the beach to their house. I was on aux and played a whole bunch of bands that we used to listen to when we took this same drive when we were little. The Beach Boys song, Wouldn't It Be Nice, came on. The song goes, wouldn't it be nice if we were older? Then we wouldn't have to wait so long. Then we could spend the day together in the kind of world where we belong. I have such a strong association of this song with my cousins, who I grew up 3,000 miles away from, and they're some of my favorite people in the world. I always wanted to be older and spend all the days with them. And I thought, we're in our 20s now. We still live 3,000 miles away from each other, but we're still those little kids who love these songs and will always have one another wherever we are.
And I want to say a big thank you to all of my friends who recorded videos, recorded audio, shared their stories, for this visualization, and just for being there for me always.
I want to say a little bit about what inspired you and how you went about this project?
Yeah, so I think for a long time I've been interested in understanding collective memory and how through interaction and specifically computational interaction, we can kind of enrich those memories that might either live in our heads alone or kind of can be expressed in a different way digitally. I think that's something that hasn't been explored to the full extent as an application of computation. And I don't know, I think it's really cool to think about the best ways to encode data, and specifically data that has more meaning than ones and zeros, like memory. So I think that was part of the inspiration for this. And then in terms of my methods, I used processing to create this, which is an extension of Java. And there's, I guess, a few layers to this. One is the touch component. So when you touch the screen, it creates these little particle systems, as you may have seen in yellow. And then when those particle systems are created, they actually get stored in a CSV file, so that when the program is run again, that data is stable within the program, so it will always return to it. So that's kind of how I made sure that that data stayed with the moments that they were collected during speech, so that they could be replayed at the right moments. So you are really building on that collective memory. And then I guess the second component is the audio visualization itself. So as you noticed, that there were kind of lines at the bottom and on the side, and that was displaying the frequencies of the audio, and also the big circle at the front of the little centipede that was running through also displayed the frequency of the audio signal that was smooth. So it wasn't looking super jaggy. And then it was moving in sinusoidal waves that were randomly generated. So that's why it can look different through each frame throughout the audio as well. And I think that mostly covers my method. Oh, and I also want to talk about the story collection method. So I asked some of my closest friends to think of stories that either reminded them of friendship or were just really strong memories, or to read an excerpt from a book that reminded them of something. And they were so kind as to do that. And then I overlaid that with piano, using an open source sound clip, and made sure that all the sounds were even, and then use that as input to the audio processing. I think that's about it.
Any other questions?
Can I ask a question?
Yeah.
The memories are, your friends are good storytellers. How about I noticed that the yellow dot seems to be replay, like their position where we touched before. But I'm not sure what's the timeline, like after which it will be replayed. Is it after each story or?
Yeah, so it's after, so if I were to run this program again, it would play during the same story at the same time. So the time that you touched it now will always be the time that you touch it in the moment of the story that you touched it. So in this iteration, when we just played it, you'd only see the things that I did where things resonated with me. So those were what was already playing without the touch, but next time this is played again, all of your touches will be shown along with the rest of the visualization.
Any other questions? Thank you so much. Okay, how's everybody doing on Zoom? Are we good? Okay, so our next presenter is Hannah Zhang, who is a Barnard College 2023 student majoring in cognitive science. And this project is an interactive heat map of New York City.
Instead of talking, I decided it would be better to just invite audience interact with the piece. yours all the time. Sure, it's the one a lot more. Please enjoy. And I think it has other basically which neighborhoods of vulnerable there's where the air conditioner, how first surface temperature is, and then how much free surface is filled out.
Kind of map out different sounds. Yeah, I and just to over that, and what the next is. Yeah.
Now rather yeah. Like try to read this whole paragraph and go through like fascinating and doubling at the same time. The fact that with the experience I think it's probably because of the display side, almost like the share. Trying to map the visceral experience with how the quality feels like in NYC. And I find fascinating that this heat as a very direct sensory experience actually reflects how much structuring there are. I try to map this with sound, with a little help from visual, because I think sound compared to purely the visualization can give you a more immersive experience of how that feels like, because it's just changing color, it doesn't give you the same sort of warping experience of being there. And this is a map that's originally visualized by NYC Environment and Health Data Portal. I took the picture, and then here, this is some of the patches by finding over the foreign accessing it, and that is what I use. So if I click in here, I can see some of the more details behind. But basically, it's a patch that allows you to translate the picture into a matrix of pixels. And each pixel, I then make another window which allows you to select which regions of the pixel you want to hear and translate that into take that RGB parameters and translate that into sound. There's two components to sound. One component is so here I'm only using the red end. The green rather than the black version. And these are just simpler semantics to allow me to translate the deeper red into more dissonant and unbearable sound. The number responds to the frequency of the sound. The first goes into this objects, which takes note. And that also triggers this PG mount, means I'm selecting which channel it is. So this repeated chord is playing channel 2, while the note is playing channel 1. And I'm also changing the instrument. So you might notice the wider area, the instrument sounds a little bit more pleasant. while in the dark area. So Friday night and AP2 were two, if you search universal media instrument number list or something, you can find how those numbers correspond to a specific instrument. So most mention the instrument. Yeah. Is that better?
Yeah, because they're saying on Zoom they couldn't hear you.
Sorry. Yeah. So I was saying I was using the RGB of the pixel color and translate them into two-channel sound, and also changing their instrument. So that the area that were wider will have a more pleasant instrument sound, while those in the darker area will have sort of more dissonant and unbearable, more electronic sound. So I'm making both the frequency and the instrument changing here. Yeah, and this toggle is just a toggle that turn on repetitive course. And this is in the backend mode, and I can always go to the presentation mode for the audience to interact. Sorry that the tag is not very visible here. Yeah.
Any questions?
I have a question just about the data here. Is Rikers looks like it's a blue color. Is it like on its own sort of index? Rikers right here. Like it looks a bit more blue than the darkest purple.
Oh yeah, I think that's probably just a mistranslation of the pixels. I do think they only use 5 scale. So I try to map the 5 color here too. But there is a possibility that when I look at data, I wasn't careful enough that maybe this is a 6. But that would make less sense because I'm not sure about the economic status of this area. It seems like they're roughly, there shouldn't be a reason why this is so bad. Yeah.
Any other questions? Okay, thank you. That was really good. Possible to share some creative presentations so I can kind of show off. So it's okay to ignite those. So we don't have to.
I don't mind because I just have to go at 1, but I'm sure we can.
Oh, okay. Why don't you go first?
Yeah, sure.
Okay. Next we have the Kai Zhang, who is a Columbia 2024 student majoring in computer science and architecture. And this project is an artistic commentary on the relationship between human emotions and technology.
Allow me some time to quickly log into the web editor I've been using. So the main medium I use for this project is feedback.js. Because I mean, I'm relatively new to the entire CS world, but like the moment when I got to know the existence of this library of JavaScript, I think it's quite inspiring and refreshing in the sense that we've been perceiving CS as a more like interaction with text. You print like hello world, but like I think what's amazing about this library is that it kind of allows you to visualize stuff. So, which is why I chose to use this one. Can we see stuff blurry on here?
The text is a little blurry on the Zoom.
Okay.
I'm not sure if that's important for your project.
Yeah, I guess I just need to show the screen. So the tags are codes, which are not that important. So how this displays visually is you have a canvas, and I think so basically our human interactors, we can input like contribute two variables here. So the first variable is like the initial position of our fingers on the screen, and also how your hand, like the trajectory drawn by the hand as you drag your arm across the screen. So I'll be doing a demonstration here on the smaller touch screen because I think this screen has to read the movement of my arm better. So if I do this,
I think that's a touch. I think we use the mouse on that. Is that right?
okay, cool. Hold on a second.
And it was tested out.
Yeah, okay, it's working now. I think it must be because I forgot to press the play button. So as we can see, this little thingy dangling here is something called like a dampened like pendulum system. So I guess what's charming about that is once it's generated, it's pretty much just like left like moving, like generating those like chaotic or like organic shapes on its own. So I think that's just the initial input you can generate with your touch. Like whether it's a single touch or it's an entire gesture made by 5 fingers. And also like as you drag your arm across the canvas, it just leaves this trajectory that will go on and on and on. So it comes in very different forms and shapes and colors. And yeah, you are welcome to interact with this either on the main screen or like on a smaller screen. So that's just the form of it. Yeah. Yeah, I guess maybe just like how we interacted with this piece, maybe like short, like careful, like touch and just drag across the screen. Yeah. Like I think we do have to like apply a little bit more here. So yeah, it just works better with the smaller screen over there because it reads whatever. But as we can see, it's generating a little shape here.
Yeah.
Oh no. I moved it.
Oh. I think we can just press refresh. Yeah, I think it's back alive again.
Can you tell us about the relationship between these molecular structures and the dragging shapes?
Yeah, so I think we're interacting with this piece using our hand. We're contributing to the initial position of it. And then after those are each individually like generated, they're kind of like just become autonomous and just like, generating different shapes or movements along the trajectory as they move. So the initial position will be determined by how you place your hands on the screen. And then like the movement, the trajectory of it is also determined by how how you're kind of like treating this entire screen as a canvas and your like arm is like a brush, just like brush across the screen. So that's kind of like how those shapes are related to our movements.
So if I put all 5 fingers, would that also shift it, or is it just the one finger?
It should be working. It should be working if you put all your 5 fingers. But yeah, I think there's some compatibility with the changing of the screen. So maybe like just a finger is a safer choice. Okay, one more thing to develop. Yeah.
And then is there any relationship to the color? Is that just random?
That's just purely random. I guess if we can play with more factors like pressure sensitivity,
Yeah.
like I think how hard you press the screen is also kind of an input that indicates what your mood is.
Yeah.
So that could be like incorporated in maybe a future version about how that further like indicates or reflects your emotion.
Yeah. Yeah.
There's a difference between just pinching the
Yeah.
screen.
Yeah. Yeah. Do you know how you would do that? To be
Yeah,
able to manage the pressure.
I have another tester for a pressure tester. I can pull it out and do a short demonstration now.
Yeah.
I think. Yeah. Hold on a second. So this is the pressure tester. So if you, I can just like, if you're trying to like, if you drag your finger across the screen, the diameter of your touch is kind of like uniform because this screen isn't really pressure sensitive. But say if you're running this code in the P5.js web editor in your iPhone or iPad, you can see like how it kind of like varies in size as you like apply different forces. So I think like pressure sensitivity, that's something existing in the P5.js library, and that's definitely something like could be incorporated like as a future feature.
Can you play the original one?
Yeah. It's kind of like scaling down a little bit.
Yeah.
Sorry. The gray one. The gray one is just like showing your trajectory in general. Yes. I think there's still also some features that I can press on it, so I kind of like change the look of it. Maybe it's better. Yeah, so there's also the option, but this is kind of using the keyboard input to change the look of it. So if you press 1, you can hide the path. If you press 2, you can hide the pendulum, like the little like dangling thingy. And there's also, if you press 4, you can kind of like change the entire skeletal look of the individual moments to a more like hair like or brush like appearance.
Yeah.
So yeah, but I think one constraint I run into is how do I implement those toggling features using just gestures. So right now those features are only like available using press on keyboards.
Mm-hmm.
So yeah, maybe that's also a thing I could play around with.
Yeah. Is it still touch sensitive on that side?
Yes, it is.
So for anyone who just walked in, you can actually go up to the wall and drag your finger if you'd like to touch it. Yeah. And then if it doesn't work as well there, you can do it on the touch screen.
Now, this one I see. Direct on, nope.
Oh. Yeah.
Sorry for disappointment. Feel free to come to this side. Yes, go ahead.
Great. I mean,
Spread a finger along.
oh, this is
Yes.
That's
Oh,
that is not.
yes, go ahead.
wonderful.
And if you want to change the appearance, you can just press on 3, 4. Yeah, so we can just like leave those like little dangling patterns there, or we can show the trajectory, or we can change the trajectory, or we can hide those, or yeah. Thank you all. Yes, yes, please.
I want to use different colors, okay?
The color is randomly generated, so yes, but go ahead.
Did anything happen?
If you don't like the current color, you can always feel free to just start a new trajectory. It will just give you a new like random color.
And how the trajectory is being generated?
So the entire like half of it is just determined by your movement, yeah, or like your hand on the time script, ideally speaking. So, but those like little dangling like pendulum system, they're so each individual edge is actually determined by the initial positions of your finger on the screen. So you can also try it, drag your entire hand across the screen. And after those pendulums are being generated, they're just kind of like autonomous. So they're just like dangling along, generate those movements, and they move across the screen. It's like this glitch. Let's just try again. Yes.
I'm gonna draw a dragon. Very cool. Wonderful.
Thank you.
Thank you. Any questions?
Yeah. It is indeed a very problematic prototype yet. So yeah. Thank you all.
Thank you so much. Okay, we have one last presentation with Kate Mock, who is a Barnard College 2025 student majoring in computer science and architecture, and this project will be an artist notebook that is used for storytelling.
I was wondering if maybe I could share my screen over Zoom. I have a presentation that goes well.
Yeah, so if you're logged into Zoom, I can do that. Just stop sharing. I think you're good to go.
Awesome. Just okay, so hi everyone, my name is Kate, and so my project today that I'll be showing to you is as I mentioned, it's an artist notebook for human and artificial storytelling. So unfortunately, some of the handwriting components for the interactive wall that I tested over the weekend are no longer working today, but I was able to collect stills from an experiment that I did to kind of demonstrate how it works. So essentially how it works is we begin when you enter the space or using the wall. A first sentence of a story is randomly generated by the OpenAI AI API. So it generates the story based on a list of topics that I'll show later. So for this, I think this exact topic that I gave the generator, I think it was write a story about a dark and stormy night. So it starts with an opening sentence. It was dark and stormy and Alice was on a mission. And here is actually this little box that the AI will generate different writing prompts to continue the story and ask you to do some more things.
So over here, there's a stylus that you use and you attach some, you add some writing, so you add your own sentence to it. And after you add your own sentence, the AI then generates another sentence in response. So in essence, what you're doing is you're writing alongside. So for example, this is one of the generated responses. So if somebody was to add some, so this is kind of a handwriting exercise that I did where you write and then you save it. And then with each time that you write a sentence, the AI then generates a different sentence based on what you've written before. So the main idea of the project that I wanted to think about is what is the create with machines instead of having almost a relationship where one instructing the other, where instead you're kind of having this productive, creative vision together. And so all of these stories then get sent to a Google Sheet when they finish. So the signal to tell the generator to finish starting the stories is when you reach, it's a visual signal. So once you reach about this part of the page, it'll generate a finale and all the stories get sent into a Google Sheet for the CSC to publish later on. Okay, so please. So these are all kind of flash fiction exercises. So to talk a little bit more about the behind the inspiration behind this project, I was inspired by this idea of generative art. So on the left, you see exhibits by Team Lab, which is an Asia-based collective, as well as on the right, the Planet Word Museum in Washington, D.C., in which it's focused on how human interaction and the idea of creation keeps generating new forms of art and material. So my main inspiration was trying to see how this could apply to storytelling, literary storytelling in specific. So this was kind of the original concept behind what you saw previously, where you have a collaborative narrative component and some art parts that I unfortunately was not able to develop fully in time. But in essence, it's always been about this idea of collaborative narrative making and interaction with the screen. And so in order to kind of implement this, I used a software called OpenAPI. So they have a generator called GPT-3 that is very, very human-like. So this, if you can see, is one of my initial experiments that I did. So the green highlighted text is all like generated by the API, and so there are commands baked into it. So if you first write the first sentence of a story about dragons, it gives a very accurate, long ago, before man ever set foot on Earth, there were dragons. You can tell by now my brain defaults to fantasy. And so the great thing about this is it feels almost generative in the sense that it can keep going, you can keep continuing the story and adding action. You can, if you don't set a limit to it, you can just keep going. So part of the experiments for this was playing with the GPT-3 has a few factors called like temperature and presence penalty. So if you increase the temperature, you get more variant creative responses. If you increase the presence penalty, you come up with things that are more divergent every single time. Now, the problem with this is it created some fun instances in which in one sentence, Alice was a witch flying on a broom. The other sentence, she was a taxi driver about to murder someone in a field. So that's why the presence penalty, as you can see, is 0. And lastly, afterwards, after all these experiments, I was able to boil down into the narrative app functionality. So this is a little bit more of the backside of how I was able to think through how each of the actions work, as well as the kind of topics that are fed in. So for example, some example topics that were hard-coded were like dinosaurs, pirates, witches, a funeral, a wedding gone wrong. And then the writing questions that kind of prompt the user and make it feel more like a collaborative exercise are things like, what about adding some action? Let's try developing the central conflict. So that's the main, actually, I think that brings it to the end of the presentation. But I also wanted to thank people who are not here because this was really a labor of love of a project. Columbia CS major Francesca Cavori helped me with the development, as well as Professor Chris Proto in the philosophy department helped me think through what it means to do this narrative interaction between computers and machines.
I'm curious about if you want to continue to develop this, so that if there is kind of like this interactive kind of storytelling component, what would be the next
Yeah, so definitely the next step is actually going to be adding illustration next to it. So I was looking at using WebGL, which is another kind of interface that does a lot of generative art, and having it respond to the text generated by the user. Yeah. So it creates like a full notebook where you have the text element and also the visual illustrations. And do you know how you want those two to kind of respond to each other? Yeah, so what I was thinking is using that kind of, as you could see earlier, there was kind of like a side where it's the user where they can kind of add their handwriting, and another side where all the stories so far is being generated. So what I was thinking is having a very light abstract art can kind of be the dynamic background behind the entire piece.
I have a question. So you had sort of a list of different topics. How much work did you have to do for each topic? Like how easy is it to create a new topic? Is it just a matter of giving a noun or two, or do you have to, like how much does OpenAI just know this stuff already and do it for you?
Yeah, actually it was very, very intuitive. So I gave about 2 or 3 examples, and afterwards I was able to come up with similar ones. The topics that I included there, those are ones that I kind of hard coded and figured out. So didn't want anything really weird to happen during the presentation.
Is this available online?
Yes, it is the open API.
No, your project.
Oh, yeah, it is on a public GitHub repository, although I have not pushed the most recent changes, but yes, it is.
Hopefully we'll find a way also just to have a gallery of all these projects.
Yeah. So, to be determined. Any other questions? Oh my God, really? Thank you so much. Well, that brings us to the end of our showcase. I just want to congratulate all of our students. You all worked so hard and the projects were incredible. We have a recording of this that somehow we'll put somewhere so that if you missed the first few projects, which were really great, you can watch those. And we have snacks for those who are in person, so please grab some snacks before you take off. And thanks again to everybody.
Thank you.